So there are several known attacks against phase-based ranging systems. One is the delay attack. The delay attack is maybe the simplest to implement, but also the simplest to mitigate. In the delay attack, we rely on the fact that the phase delay, if you add a constant phase delay, that's like increasing the distance. And what happens at some point is the modulo math, your delta phase, the signals will wrap around. So if you can cause a phase delay that's constant, that is the correct value to cause the phases to wrap around, it will be ambiguous with a shorter distance. Right? So if you were, say, at 150 meters and you added 20 meters worth of phase delay, that would be ambiguous to 10 meters. Right? So you would have lowered the distance measurement by 130 meters. Fortunately, the ambiguity between round trip time and your phase-based measurement is going to be more than 100 meters. So it's very easy to detect. So we don't think it's a very realistic attack because RTT very easily detects that. Even the non-sophisticated versions of RTT can protect against that. The next type of attack, actually the next two are very similar. I'll say the difference between the two is an assumption of whether you can physically cut off the link between the two victims, or if you are trying to add your signal to the true transmitter. But they're the same type of attack. And this type of attack, you have to measure what the transmitter is sending, figure out what their phase trajectory is. Then you need to adjust the phase trajectory such that the result of the phase measurements that I showed on the previous chart, the progression, results in the distance that you want. So that means on a per frequency basis, you need to either add or subtract phase so that the distance calculation will be what you want it to be. So that revolves around first detecting the phase, calculating what you want the new phase to be, and then outputting that. And the Bluetooth SIG spec has several protections against that. The first protection is, in the literature, they show this is quite easy to do if you know what the frequency ordering is. But in channel sounding systems, the frequency order is cryptographically random. So an attacker won't know the frequency ahead of time, which means they can't adjust the frequency without first measuring the frequency and the tone and calculations. So that makes it a little bit more difficult. The other thing that the SIG spec has done is they added quality bits. So that means the distortion that an attacker would create as they're trying to measure the phase with the true phase and then manipulate the phase, they may change the amplitude of it, and they will certainly cause a phase glitch, and the quality bits can more than likely detect that. And then the final protection is the antenna paths, when you use multiple antenna paths, that are randomized in order. So the attacker would have to know which antenna path is used such that they're attacking the correct antenna path. Because if they make the wrong assumption about the wrong antenna path, then they put the wrong phase in. So this makes attacking phase-based ranging difficult, but not impossible, which is the reason why the SIG spec has a separate mechanism, independent mechanism of round trip time.